Hey, what's up, Algebra 2? It's Ryan. Today we're going to be going over factoring and solving polynomials. So far we've worked with quadratics, so second degree polynomials. But we're going to see third degree and fourth degree and fifth degree, all the way up polynomials. And right, by the way, just as a side note, polynomials just means multiple terms. So in this case, we have 3 terms, trinomial. In this case, we have 2 terms, binomial. Poly just means multiple terms. So anyways, we want to learn how to factor and solve polynomials that are of a higher degree. So that's what we're going to be working on today. So let's start with some review. First, we have this quadratic, 6x squared plus 33x plus 36. So we should see, originally, we want to simplify this. So we should see that we want to factor out a 3. Right, we have a common factor. So we factor out a 3 and we get 2x squared plus 11x plus 12. Now, a lot of people have their different ways of solving it. This type of quadratic, when we have an a value greater than 1, what I do is I multiply a and c. So a times c, which is 2 times 12. 2 times 12. 12 times 2, it doesn't really matter. Equals 24. And then what factors of 24 add to 11? 8 and 3. So 8 times 3 equals 24, and 8 plus 3 equals 11. So I say 2x squared plus 8x plus 3x plus, and then 12. And right, this is equivalent to our parentheses. And then I just factor out a 2x out of these first 2 terms. So I factor out 2x and I get x plus 4. Then I factor out a 3 out of these last 2 terms. I get x plus 4. And then I can take this 2 and this 3. I have 2x plus 3 since they're both multiplying by x times 4. And then do x plus 4 here. And so I know our final answer for this is going to be, we still have this 3 out front, then it's 2x plus 3, then x plus 4. At least that's how I do it. A lot of people have different ways. You can, since this is only 2, you can just say 2x, x, and then just plug in a bunch of different things and see what works. Okay, for a trinomial like this, it's pretty simple. We want to find 2 numbers that multiply to negative 12 and add to negative 4. So we find that negative 6 and 2 do that, negative 6 and positive 2. So we have x minus 6, x plus 2, and that's just how we factor it. And then here we have a perfect square trinomial. So we notice that our c value is a perfect square. And so what's the square root of 110? And so when we do negative 10 times negative 10 gives us positive 100, and positive 10 times positive 10 gives us 102. But we want our b value to be negative 20. So we want, when we multiply whatever that square root of 100 to be, we want it to add to negative 20. That's just a long way of saying eventually this comes out to be x minus 10 squared. Okay? Sorry. And then we also have the difference of 2 squares. So this is where our b value is 0, so we don't have a b term. And this is where our first term, we'll have x squared or something. And then our second term, our c value will also be a perfect square, and there has to be a minus sign in between. So the square root of x squared is just x. The square root of 49 is 7. So we're going to have x and 7. And we want to have it, the 2 terms be opposite signs, because we want these 2 parentheses to be conjugates of each other. And if you recall, we did this. I think we did this when we talked about I remember talking about this. But when we eventually FOIL these out, right, we get x squared, and then we get plus 7x from here, and then we get minus 7x from here, and then we get minus 49. These two eventually just cancel out. That's how we get x squared minus 49. If that makes sense. Okay, so we have a couple of strategies to solve these different types of quadratics. But what about cubes, right? And so that's what we see here. One type of problem we're going to go over in Algebra 2 is the sum of two cubes and the difference of two cubes. And essentially, what we'll have here is we'll have a to the third, so some value to the third, plus or minus, in this case if we're doing difference, b to the third. And I'll show this in an example and we'll get more practice. But essentially, if we're adding these two, eventually we're gonna, the factored form is gonna look something like this. And so it's a plus b in parentheses times a squared minus ab plus b squared. And here, for difference of two cubes, it's going to be a minus b times a squared plus ab plus b squared. So you see that these pluses and minuses, these signs, vary. And the way we remember which sign to use when is by this acronym SOAP. So SOAP stands for same, opposite, always positive. So if you'll see here in our sum of two cubes, we have an addition. So we want our first sign to be the same sign, so we want a plus sign here. And then we want the opposite sign, so I'm going to do this in red. So we have a plus sign first. Actually, you know what, maybe a plus sign first. Then we want the opposite sign. So the opposite of a plus is a minus sign, and then the last term is always positive, so it's always going to be plus b squared. We see the same thing here. When we have a negative sign, the difference of two cubes, we have a negative, and then we want the opposite of a negative, so a positive, and then we always have a positive here. Okay, I'll show you this in action in example number 1. Okay, so we want to convert this into the form of let me reword this. This is already in the form of a to the third minus b to the third. So this is going to be a difference of two cubes. Now we want to find the values of a and b. So if a to the third equals x to the third, a equals what? It's just going to equal x. If b to the third equals 125, then what's b going to equal? This cube root of 125 is just going to be 5. Okay? So now we have our values for a and b. And we just want to sub that into this equation. So we have a minus b. I'm going to write this here. A minus b, so x minus 5. And we do a minus because we want this same sign as our original. Then we have a squared, which is x squared. Then we want a positive, right, because we want the opposite of a negative, plus, and then a times b, so 5 times x, 5x, and then always positive, plus b squared. 5 squared is 25, and that's our factored form. Let's do that here with the sum of two cubes in example A. So what's a equal to? A is equal to x. What's b equal to? Well, b is equal to the cube root of 64, which is just going to be 4. So we want our factored form to be x, same sign, plus 4. Now we want to do a squared, so x squared. Sorry, I was about to write a. X squared. Now we want to do the opposite sign, so a minus sign. B times a, or a times b, same thing, minus 4x, always positive, b squared, 16. Great. Hopefully that makes sense. Now let's do c. You can try b by yourself. It's going to use the same concept as c. But we want to find, so I'm going to write this out again, a cubed. So first of all, we notice this is the sum of two cubes. Okay, a cubed is going to be equal to 343x cubed. So what's a going to be equal to? Well, we need to take the square or cube root of both sides, and this gives us a equals, and the cube root of 343 is just going to be 7. And the cube root of x to the third is just going to be x. So a equals 7x. Then we also have b cubed equals 1000. And then again, we want to take the cube root of both sides. And the cube root of 1000 is just going to be 10. It can be helpful to memorize your cube roots, your square roots. Yeah. And it also, you can just know 10 to whatever power is just going to be however many zeros there are. So for example, 10 to the second power, 10 squared, 100 has 2 zeros. 10 to the third power has 3 zeros, 1000. Okay, so we have our values for a and b. Now we just want to sub that into our formula. So since this is sum of cubes, we first want to start off with a plus. So we have a plus b, so 7x plus 10. Now we want a squared, so 7x squared is going to be 49x squared, since we want to square both the 7 and the x. Then we want to do the opposite sign, so a minus instead of a plus. A times b, so 70x, because we do 7x times 10. And then always positive, b squared, so 10 squared is just going to be 100. And that's our answer. Okay, so another strategy is factoring by grouping. So this is actually similar to the strategy I used up here, except we can use that same strategy or something similar, the second half of it, with polynomials of higher degree. So for example, here what we want to do is we first want to separate this into two binomials. So we have x to the third minus 3x squared plus 6x minus 18. This might be helpful to write out here. Now, we want to factor out the greatest common factor from both of these binomials. So what's the greatest common factor of x cubed minus 3x squared? Well, that's just going to be x squared. And when we factor that out, we get x minus 3. Then conversely, here we also want to factor out the greatest common factor out of this binomial. So the greatest common factor of 6x minus 18 is 6. Then we have x minus 3. Notice we have the same term in parentheses, or expression, whatever. So here we can factor out this new greatest common factor, we can combine these and say x squared minus 6 times x minus 3. And that's going to be your answer. And in this case, you should be on the lookout for, say this was x squared minus 4. You should be on the lookout if you can simplify this anymore. So for example, if this was x minus 4, you could simplify it into x plus 2 times x minus 2. Then you'd still have this x minus 3. Okay, great. Let's try to implement this on some practice problems. So first we want to separate into two binomials. I'm just going to do that by putting parentheses around this. The greatest common factor we can factor out of x cubed plus 6x squared is x squared. Then we have x, we're left with x plus 6. The greatest common factor we can factor out of 7x plus 42 is 7. So we do x plus 6 again. We're left with 2x plus 6's. So we can combine x squared plus 7 and x plus 6 as our answer. Let's also do, let's do D. Okay, so first separate into two binomials. And I'm going to write this as plus negative, if you can see that. Okay, I know it's not great, but we still have that negative sign. Just remember that. So the greatest common factor we can factor out of 9x cubed plus 18x squared is 9x squared. So we factor that out. We're left with x plus 2. And here, the greatest common factor we can factor out of negative 4x minus 8 is going to be negative 4. So we bring out that negative 4 and we're left with x plus 2. Okay, great. Now, what we can do is we have these x plus 2's, so we can combine 9x squared minus 4 and x plus 2. Great. Now, one might think we're done here, but we're actually not. So this is what I was talking about before. Keep in mind that you may have to simplify this expression more. So in this case, we can. And it's actually using, let's see, the difference of two squares. And remember how we had conjugates? We found the square root of x squared, which is x, the square root of 49, which is 7, and add a plus and a minus. Wait, is that the case here? Yeah. So we're going to do the same thing. What's the square root of x squared? 3x. What's the square root of 4? 2. And we have no b term, so we can say 3x plus 2 and 3x minus 2. And that FOILed out will give us 9x squared minus 4. We still have this x plus 2. So this all is that. Okay, hopefully that makes sense. Now let's move on to quadratic form. So some polynomials follow a quadratic pattern, but just have higher exponents. So let's look at this in example 3. We have x to the 4th minus 4x squared minus 21. So you might think, oh, I don't know how to factor this, right? But what if I were to say u equals x squared? And every single time you see x squared, you just sub that in for 2. So for example, when we have x to the 4th, that's the same thing as saying x squared, right? Because remember our exponent rules from that we learned last lecture. we multiply these two exponents and we get 4. And wherever I see an x squared, I can just sub in a 4, so this is equal to u squared. So instead of writing x to the 4th, I'm just going to write u squared minus 4. I have another x squared. I'm going to write u minus 21. Then you just factor this normally. What are two numbers that multiply to negative 21 and add to negative 4? Well, that's going to be negative 7 and positive 3. So we do u minus 7, u plus 3. And now we just sub back in x squared. So we have x squared minus 7 and x squared plus 3. Keep in mind, when you do this, you do want to check if you can simplify. In this case, we can't simplify. So here we have x to the 6th minus 4. So I guess my question to you is, what do we want u to equal in this case so that it becomes a quadratic we can easily factor? Well, eventually I want to get it into the form u squared minus 4. So what value of u is going to get? It's going to be, or what is u going to be equal to achieve this? Well, if we want, what we can essentially just say, if we want x to the 6th to be equal to u squared, well, we can just square root both sides, do whatever, and square rooting, or yeah, I don't know if people know this yet, but essentially square rooting is dividing this exponent by 2. So we get x to the 3rd equals u, because essentially a square root is something to the 1/2 power. And you remember, if I were to raise x to the 6th to the 1/2 power, we're multiplying 6 and 1/2. That gives us x to the 3rd. So we get u equals x to the 3rd. And we have u minus 4. How do we factor that? It's different of squares. So we have conjugates. We do, sorry, not u plus 4. I'm tripping. The square root of u squared is u. The square root of 4 is 2. So u plus 2 and u minus 2. We just sub in x cubed for u. So x to the 3rd, oh, that's bad, 3. X to the 3rd plus 2. X to the 3rd, oh Lord. X to the 3rd minus 2. Great. Okay, so you can try this one by yourself. Now let's move on to example 5. This is going to be our last example. Okay, so we want to solve this. First thing we want to do is get everything to the left side. So I'm going to rewrite this as 2x to the 5th plus 24x, or you know what, actually, I'm not going to write it like that, minus 14x squared, or x cubed plus 24x equals 0. Just because I'm subtracting 14x squared from both sides. Now I'm going to take out the greatest common factor out of all of these. So in this case, I'm going to factor out a 2x. 2x, and when I factor out a 2x, I get x to the 4th minus 7x squared plus 12 equals 0. I'm just going to leave this and keep on going. So anyways, we have u in our parentheses, we have u to the 4th minus 7x squared plus 12. What do you think we can do about that? How do you think we can solve this? Well, we're going to say x squared equals u, and sub in u. So x to the fourth is just going to be equal to u squared, since all of this squared would give us x to the fourth, right, because we multiply 2 times 2, minus 7u plus 12. We still have that 2x outside. I'm just going to leave that there for now. Now we want to find two numbers that multiply to positive 12 and add to negative 7. That's going to be negative 4 and negative 3. So I'm going to say u minus 3 and u minus 4 equal to 0. Just going to keep on going down here. Now we want to sub back in x squared for u. So we have x squared minus 3, x squared minus 4 equals u, or equals 0, sorry. And then what I'm going to do is we can simplify this because it's difference of squares. So I'm going to say 2x, and then x squared minus 3. And we want to take the square root of x, which is x, and the square root of 4, which is 2. And we just want to have two different signs so that they're conjugates of one another and they don't have or so that their b value is 0. They don't have a b term. And all of this is still equal to 0. So now we have everything in factored form, and we want to determine the values that make each factor equal to 0. So in this case, first of all, sorry, I'm trying to find the best way to explain this. Since we're multiplying every single one of these parentheses and 2x and all that, if any one of these parentheses or 2x are equal to 0, the entire left side is going to be equal to 0. So we just want to set each of these equal to 0. So, for example, 2x equals 0. X squared minus 3 equals 0. X plus 2 equals 0. And x minus 2 equals 0. This is going to give us, well, if we divide by 2, it does not really matter. We just get x equals 0 for this first one. And we move this 3 over. I'll just erase, actually. And I'll say x squared equals 3. So x is going to equal plus or minus, remember that plus or minus, root 3. Then we just move that 2 over, so we get x equals negative 2 and x equals positive 2 here. So these are each going to be, and you know what, I'll just write it out. X equals 0, x equals plus or minus root 3, and x equals plus or minus 2. Each of these are going to be the solutions to that polynomial equation. Okay, great. If you have any questions on what I did here, go to your teacher, go to the tutoring center. Definitely feel free to use me as a resource. That's why I'm here. Use the internet, and also reference your classmates. Your classmates, they have the same experience as you, but if they're a little bit more knowledgeable or they know what they're doing, go to them, ask them. I also find it, at least for me, I find it easier to learn from someone else my age who's gone through this same thing, who's in the same class, who has the same teacher. Or it can be someone with a different teacher. But anyways, just reference your classmates, work with your peers. And yeah, good luck. See ya.